Hello, so in this video we will cover all of the Unit 3 questions in the midterm review packet. So that's going to be questions 15 through 17. Okay, make sure for this section you have your periodic table handy because you will definitely need your periodic table to fill out the chart with all the proton, neutron, and electron calculations in 16b. Okay, so starting with question 15 here. So it's asking you to write a summary, quick information about all the scientists mentioned here. So all these men were the ones we mentioned in terms of the development of the atomic model. So how did we get to our current understanding of the atom? Now, I'm not going to go through all of these because you should go back into your Unit 3 notes and look these up. Now, you may have done a web quest to find out about these gentlemen. You also could have gotten a handout that had the timeline with all these people's information as well, or you might have just covered it in the notes depending on how your teacher did it. Either way, what you want to look for are a few key pieces of information. So first thing you want to know and fill out for each of these gentlemen is their name. So obviously we want to know the name, which you already have. You want to know what their sort of big discovery was. So in other words, why were we talking about them? What did they do? Why were they worth mentioning about the development of the atomic model? You also want to know their experiment, if they had one. Not everyone had a specific one that we mentioned, but some of them did. And then last but not least, if they had one, you want to mention the atomic model they developed. Okay, so again, you should go back into your notes and fill in this whole section, keeping in mind these pieces of information. So just as an example, not all of these people have all 4 of these pieces of information, but some do. So for example, Thomson, we could say, for J.J. Thomson, he discovered the electron by his experiments with cathode ray tubes, which led to his development of the plum pudding model of the atom. So look back through your notes, jot something down, maybe sketch out the atomic model for the relevant scientists. Okay? Moving on to question 16a, it's asking you to complete this table, and you should have in your notes from Unit 3 something that will fill this out very quickly as well. So please feel free to turn to that to make sure you get all this information. But the key pieces of info to know: protons, depending on your teacher, they could have abbreviated as just P or P+. Neutrons are generally N or N naught, and then electrons are usually E-. Okay? Protons and neutrons, remember, are exactly the same in terms of their structure. They have the same mass and the same location. They're both in the nucleus. The only difference between these two is that protons have a +1 charge and neutrons are neutral. Electrons do have mass because they are matter, but it's so small it's almost negligible. So we could say that their mass is almost 0, but we know that their charge is -1, and they are actually outside the nucleus in what we would call the electron cloud. Depending on the model, that might look different from one to the other, but the point is they're outside the nucleus, unlike the protons and neutrons. Okay? So get your periodic tables ready as we go to question 16b, because here's where we have one of our proton, neutron, electron charts. So looking at our chart here, before we get into specific questions, let's remind ourselves of a few formulas that we were using to help us out with these. Okay? So the first thing we want to remember is that our atomic number and the number of protons are always equal. So let's just jot some reminders down to ourselves in the heading. The atomic number is equal to the number of protons, and the number of protons is equal to the atomic number. Okay? We also talked about how the mass number is the sum of the protons plus the neutrons, which means that our number of neutrons would be the mass number minus the protons. Okay, and the rest we have to figure out. Oh, actually, one more we can write down, our isotope notation. So the isotope notation was always the symbol of the element. If there was a charge, it goes in the upper right. In the upper left was the mass number, and the lower left was the atomic number. Okay, now the charge we have to figure out based on the protons and electrons. If you have more protons, that means you have a positive charge. If you have more electrons, that means you have a negative charge. So you have to compare those two columns and figure it out. If they are equal, that means that your charge is 0, or in other words, it's neutral. Okay? So, let's work our way through this and see what we can do. We will want, like I said, we will want our periodic table for this. So I'll keep one up on the screen for the first couple as we fill them in, and then you should follow along on your own as well. So let me add the periodic table. Okay, so here's our periodic table overlaid just so we can see where some of these values are coming from. So for this first column, or excuse me, for this first row, truly, the only thing we know is that our element is sodium. So since our element is sodium, I know that the symbol would be Na. This 25 is always the mass number, so that would go in the upper left here and right here. The atomic number for sodium, if we look on our periodic table, the atomic number would be 11. So we can fill that in there and there, as well as there. And as far as the charge goes, it said that we had a charge of 0, which means we have equal numbers of protons and electrons. Now, we can leave our symbol like this, or you could write a 0 there if you would like, but you do not have to. So, that's how we would do our first one. If we know which element it is, that helps us out a lot. Okay? But now let's move on to the second question. So, scoot this down. All right, so looking at our second row here, what do we know this time? We know that our element is fluorine because we had the symbol, so we can fill that in. The mass number we know was 17 because it said it right there, and it says it right here. We know that our atomic number is 9, which means we have 9 protons as well, which makes sense because 9 is the atomic number for fluorine. In terms of the number of neutrons, if our number of neutrons is the mass number, which is 17, minus the number of protons, which is 9, we know that that means we would have 8 neutrons total. As for the electrons, since we have a charge of 0, that means we have equal numbers of protons and electrons. So there we are. Okay? So there's that next one. Moving to the next one. In this case, we know the number of protons is 35, which means that's also our atomic number. Once we know the atomic number, we should look to the periodic table and see that the 35th element is bromine, right here, right? So we know now that this would be bromine, and the mass number was 80. So in our symbol, we have the mass number in the upper left, the atomic number in the lower left. As far as the charge goes, again, it was 0. So that means if we have 35 electrons, we have 35 protons, which makes sense. In terms of our neutrons, we would again need to do the mass number, which is 80 this time, minus the number of protons, and that's going to give us 45 neutrons. Okay, so there we are. Moving on to our next one. Here's the first one where we have a charge that is not equal to 0. So, the first thing we know is that our element is calcium because we have this symbol written there. So notice that on the periodic table, calcium is right here, and it's the 20th element. So that means our atomic number is 20. So we can fill that in there and there. And we already had that we had 20 protons, so that makes sense. We would write our name out, calcium, dash 40. Since our charge was +2, that means I have 2 more positives than negative, 2 more protons. So if I have 20 protons, that means I need 18 electrons to still leave me with 2 extra protons. As far as the neutrons go, 40 is our mass number, minus our 20 protons gives us 20 neutrons. Okay? So, for these last couple, I'm going to go through them a little bit quicker. I'm going to get rid of the periodic table just so we can see them all. But again, you would want your periodic table here handy as well so that you can complete your table. Okay? So I will talk through it, but feel free to pause and refer to your periodic table as we continue. So for the next one, I know that the atomic number is 1, which means this is hydrogen because that's the first element on the periodic table. The mass number, it said, was 2. Our symbol would be H. Mass number, atomic number. As far as the charge goes, if the atomic number is 1, that means we have 1 proton. So if I have 1 proton and 0 electrons, I have 1 positive and no negatives, so our charge would be +1, So I should write that back here in my symbol. And then for our neutrons, 2 minus 1 would give us 1 proton. For the next one, this time I know the mass number, neutrons, and the charge, which seems like we don't really have enough, but we can work backwards here. If we know the mass number and the number of neutrons, we can figure out the number of protons. So our mass number, 222, minus the number of neutrons is going to give us the number of protons, which we would see is 86. Since it's the 86 for our protons, that means we also have the atomic number of 86. If you look on your periodic table, you'll see that radon is the 86th element. And then we put our mass number after the dash. The symbol for radon is Rn. We have our mass number, our atomic number, and it said it had a charge of 0. So if I have 86 protons, we also would have 86 electrons. For the next one, we know our element is magnesium because we had the symbol. The mass number we don't know yet, so we're going to have to fill that in a moment. But I know that the charge is +2 because it had it in the symbol right there. If we know the element is magnesium, look on the periodic table to see what the atomic number for magnesium is, and you would see that it is 12, which means we have 12 there. 12 there as the atomic number, and 12 protons. Okay. If our charge is +2 and we have 12 positives, that means we must have 10 negatives to leave us with a charge of +2, so 10 electrons. The last thing we need is the mass number. The mass number, remember, is the sum of the protons plus the neutrons. So if I do the 12 protons plus the 12 neutrons, we see that our mass number is 24 to finish us off. Okay, 3 more. All right, on to the chlorines. So I know it's chlorine because we had the symbol. The mass number told us is 35. If we don't know the atomic number, look on the periodic table and see that chlorine is the 17th element, which means we have 17 protons. This is the first one where we have a negative charge, right? This tells us that right there. So if I have a negative charge, that means I have more electrons than protons, 1 more. So if I have 17 protons, I must have 18 electrons to leave us with -1 overall. For our neutrons, in this case, we know the mass number is 35 minus the number of protons, and we see that that would leave us with 18 neutrons. Okay? On to the next one. So we know our element is lead, which has the symbol Pb. We know the mass number. If you look up lead on the periodic table, you'll find that its atomic number is 82. It's the 82nd element. And we're told over here that the charge is +4. So let's fill everything in. We have 82 protons because it's the same as the atomic number. If we have a +4 charge, that means I have 4 more protons than electrons. So that must be 78 electrons. And to get our number of neutrons, the mass number minus the number of protons would leave us with 125 neutrons. Last one of the bunch. Sodium has a symbol of Na. It says the mass number is 23. If you look up sodium on the periodic table, it is the 11th element, meaning our atomic number is 11, and we have 11 protons. It tells us the charge is +1. So if I have 11 positives, I must have 10 electrons, 10 negatives, to leave me with 1 extra positive. To get our neutrons, 23 minus 11 means we have 12 neutrons. So there's our whole chart. Now, to move to our last question of the unit. Question 17 asks, what is the atomic mass of carbon, knowing it consists of 20% carbon-12, 20% carbon-14, and 60% carbon-13? So the first thing we need to note is that we are doing a weighted average here. Average atomic mass is always a weighted average. So, a weighted average means that we need to multiply each mass number multiplied by its percent abundance as a decimal, which means it's percent divided by 100, essentially. Okay? So if we do that for each of these 3 isotopes, the 3 different versions of carbon, the 3 different masses of carbon, and we add them all up, we will get our average atomic mass. So let's do that. We'll take the average atomic mass of the first one, which, remember, the mass number is after the dash here, so we're assuming that those are the masses, and our unit is AMU, atomic mass unit. So if we do 12 AMU multiplied by 20% divided by 100, you would get 2.4 AMU. And do the same thing for the others. The second isotope had the mass number of 14, and it also had a percent of 20, meaning 20% of the carbon in the world weighs this 14 AMU. You would get that. And then our last isotope had the mass number of 13 and a percent abundance of 60, meaning most of the carbon in the world weighs this 13 AMU. Okay, so that would give me those three values. Now the question is, what do I do with them? This is the contribution from each of the isotopes, so I want to add this all together to get my total. So if you add together 2.4 plus 2.8 plus 7.8, you would get 13 AMU. Now, I know you're tempted to divide by 3 here, but if you divide 13 by 3, your answer won't make sense anymore because our average has to be between 12, 13, and 14. So we would indeed get that. Coincidentally, it comes out to a whole number. It will not always, but this would be our weighted average. It makes sense. If we look on the periodic table, 13 is around the average mass for carbon. These numbers could be a little bit more specific if we wanted to get this answer a little bit more precise. But those are all of our questions from Unit 2. The next video will cover, Unit 3. The next video will cover Unit 4.